Okay, so we're going to talk about different triangle properties, and you may or may not have already tried this Desmos activity. There's lots of fun things to remind you of some of the properties of triangles that you already know, and some definitions and things like that. But we're just going to move on, assuming that you've done that, and summarize what you've learned. So we have the different triangles. We, of course, remember probably the one that we come across first is this one, the equilateral, where all the sides and all the angles are equal. When only two sides and two angles are equal, that's called isosceles. And when all of them are different, all the sides are different, that will result in different angles, we call that one scalene. And then when we look at the different type of triangles that are classified by their angles, we could have, this one is probably the most popular one. It's got a right angle and 90 degrees into it. And then when all the angles inside that triangle are less than 90 degrees, we call that acute triangle. And when one of them is greater than 90 degrees, then we call that one obtuse. So that just sort of is a little bit of review of the triangle stuff that we've seen in the past. Now, the rule or the property that we've probably known for a while now is that all the interior angles of a triangle add up to 180 degrees. And we've seen multiples of reasons why that is, and lots of demonstrations. It was even in the Desmos activity there. You saw this property here where it didn't matter what type of triangle you created. If you take them all and add them up, you see there the different angles. They add up to 180 degrees. Okay. So that one is a property we're pretty familiar with. What you might not be as familiar with are the sum of the exterior angles. So here's an example of a triangle that's moving around here to show you the exterior angles. So I'm just going to grab it here to stop it. So we see we've got this exterior angle at A is the one that goes from here to here as if we extended that. Here's one at B that goes from here to here, and here's one at C. And it says that the sum of those is 360. And it may be hard to visualize that until we do something kind of neat like this, where we make a really tiny, tiny triangle. And then you can see how all of the outside exterior angles all will make up a part of a circle. If we brought this infinitely tiny, you could definitely see that they're all add up to 360. So this is kind of a new, maybe a new property to you, but that's kind of a neat little idea, concept, that the sum of the exterior angles in a triangle add up to 360 degrees. And also within that exercise, you found that the angle here can be found by taking this angle plus this angle. If you take the sum of those, it equals the exterior angle on the opposite side. So those are all conclusions from the Desmos activity. What we're going to do now is use these concepts to answer a couple of questions. Oh, sorry, before we go to that, know that some of these rules also apply for quadrilaterals. All right, so we've got different quadrilaterals. So the difference between a triangle and a quadrilateral. A triangle, of course, is tri for three sides. A quadrilateral stands for four sides. And so we have the different quadrilaterals. The one we're probably, of course, been very familiar with is a rectangle. It has opposite sides are equal, and they're all right angles in the corner. If all the sides were the same, that's a special rectangle called a square. If the angles are not 90 degrees, but all the sides are the same, then it's tilted like that. It's called a rhombus. If you have a rectangle that is not 90 degrees, but the opposite sides are equal and not the same, then that's called a parallelogram. And then a trapezoid only has this side parallel to this side, but the other opposite sides are not parallel. So it gets it a little bit twisted, and we have that. But the sum of an interior angle of a quadrilateral, all the angles inside of a quadrilateral add up to 360. And there's a really cool little demonstration as to why that is. Let's take that rectangle that's above there and cut it in half, and we get two triangles. We get a triangle here and a triangle here. And if you add all the angles in this triangle, that's 180. On this triangle, you get 180. So in a rectangle, it's going to be 360. But the exterior angles, well, the exterior angles are also add up to 360. So it's the same reason the triangle, the exterior angles up to 360, all the exterior angles of a quadrilateral would add up to 360. So if I looked at extended all these, and I take this one, plus this one, plus this one, plus this one, again, imagine you shrunk this really close, you'd still get that circular idea. So exterior angles of a quadrilateral is 360 degrees as well. In fact, any polygon, the exterior angles are always going to add up to 360. The interior is going to be different. A triangle is 180, a quadrilateral is 360. All right, so a couple of summary slides there, but then let's actually use these to answer a couple of questions. So in this, we do like to use algebra, but we can use our logic as well, and different people see these differently. They're all good answers. In this one, in the first one, I know that I've got a triangle and I know two of the angles, so I have to figure out the third angle. So there are two different approaches that students usually take when we do this. One is this, saying, okay, I've got this angle and this angle. I know that it's 180 degrees in total. If I take away the 61 and take away the 39, then what I'm left with must be what x is. And if I take away those, I get that it's 80 degrees. And that's one way you can visualize it. The other way that we've seen people do this is they say, okay, I've got two angles that I know. So they do 39 plus 61, and that gets me 100. So I've used up 100 degrees, and now I do 180 minus that 100 means that I have 80 left over as my x. Both of those are equally good logic. I wouldn't say one is better than the other. And as long as you're showing me your steps, you both get the same answer of 80 degrees, and that would be totally fine. So now let's try a second example here. Now this is a quadrilateral, and remember a quadrilateral adds up to 360 degrees. The interior angles add up to 360. So if I have 360 in total, I'm going to take away the ones that I know. Well, I'm going to take away 66. I'll take away 128. And I'll take away this one, and I know most of you, actually every one of you, knows that that one is 90 degrees. That's the symbol we use for 90, a little square in the corner, because the corner is perfectly square. So if we take 360, subtract the 66, subtract 128, and subtract the 90, that means we're left with 76. And you can double check that on your calculator, that this one must be 76. Others will do it the other way, which is just equally as good. They would take the angles that I know, so 66 plus 128 plus 90, and say, okay, add those up, and I get 284. So that's how many degrees I've used. I know that there's 360 in total, so if I subtract the 284, then that would leave me with the 76 degrees, which is the same as what I have here, and that would get that. So again, I'm not saying one is better than the other. They're both good ideas, and so I would encourage you to use whichever one you're more comfortable with. All right, let's look at C. In C, we have a different type of triangle. If I was teaching this live, I would ask you which triangle this is. You might be staring at the screen and saying it's an isosceles triangle. The clue that it's isosceles are these little ticks to say that those two sides are equal. Because those two sides are equal, we know another property of isosceles triangles is that this angle equals this angle. So, in this case, it looks like I only know one bit of information, the 30 degrees, which is true. So I could go and say, okay, well I have 180 in total, because it's a triangle, and I'm going to take away 30. That means I have 150 left over. But because I know that these two are equal, that 150 degrees must be divided equally amongst these two. So I'm going to say 150 divided by 2 means that each angle must be 75 degrees. And you can check that, do 75 plus 75 plus 30, and it should add up to 180. And so that's a common one that we like to do with isosceles triangles, to take advantage of that information we know about isosceles triangles. All right, so now let's look at exterior angles. So one of the properties that we used in that we might have discovered in the Desmos activity is that this angle, this exterior angle, is equal to the sum of these two interior angles. And so I can quickly get x equals 44 plus 78, go to my calculator and add those up and get 122. And that's the shortcut if we remember the property of exterior angles and how it's related to an interior, the sum of the interior angles. But if you forget that, I know that you could use your logic as well. I know we want to find this one, but instead, I'm curious, let's find this one first. So I can see there that that's the third angle in a 180 degree triangle. So I could do 180 minus 78 minus 44 and get that that is 58 degrees. Or you could add up 78 plus 44 and subtract it from 180, the same thing. So I just figured out that this is 58. Now I could look and see that I've got a straight line here. And if you remember your properties of straight lines, this angle plus this angle must add up to 180. A straight line is 180 degrees. So I could say, well, if this one is 58, then I could go 180 minus 58, and that equals 122. And so this angle must be 122. Well, that's good news because it's exactly the same as the property that we found here. That's just taking those and adding it up. So again, both ways. I'm not saying one is easier than, or better than the other. The green method uses the property, so it's a little bit quicker. But the blue method, blue and red method, use logic and get you to the same spot. So that would be fine. All right, let's look at example 2. Example 2 has a quadrilateral, but almost all of the exterior angles. And remember, it doesn't matter the shape of the polygon, all the exterior angles, this one plus this one plus this one plus this one, are going to add up to 360. So I could subtract the ones that I know, 88, 113, and 92. If I subtract all those, I get 67, must be the value for this angle. Or, again, I can add up the ones I know, so 88 plus 113 plus 92, that's going to add up to 293. And I know all of the angles, exterior angles, add up to 360, so if I subtract the 293, I get 67, which is the same as the answer that I had there. And so that's just using one of the new, maybe the new ideas or new properties that we learned about exterior angles adding up to 360. Next, we're going to take both of these concepts about some of the properties of triangles and do a little bit of algebra to solve some interesting questions here. So this is a great spot for us to practice our algebra because it's going to be stuff we're using all year, alongside with the measurement that we've been just talking about today. So you see here, instead of having numbers for all the sides, I don't know, or all the angles, I don't know any of the angles. But I do know the property that says that this angle, no matter how big it is, plus this angle must add up to 180 degrees. So let's write that algebraic statement. X plus 3x plus 5x must add up to 180 degrees. And this means we can use collecting like terms to solve this algebraic equation. So, great spot to practice collecting like terms. I've got this x, which is just 1x, plus 3 more, plus 5 more is a total of 8x. Oh, excuse me, 9x. 1 plus 3 is 4, plus 5 is 9. 9x. And if I have 9 cups and 180 cubes, I want to know what's under each cup, or each x. I have to divide both sides by 9. And 180 divided by 9 is 20. So that allowed us to do a little bit of algebra to solve the x values in this question. So that means that this must be 20. Now that doesn't mean the other sides are 20, but it does say that if x is 20, this one is 3 times x. So 3 times 20. It's 3 times bigger, so that's 60. So that angle there is 60. And then the last angle is 5 times 20, which gets me 100. And again, I feel pretty good about that because if I just added these up, 100 plus 60 is 160, plus 20 more gets me 120. And so we have our correct answer. So this is a great one to practice our algebra and our triangle properties at the same time. So I'm going to give you a chance to do a couple of them on the whiteboard. If you'd like to pause the video, you can. And then I'll come back and show you the answers. Okay, so you've had a chance to maybe try these on the whiteboard. So you see that in the first case, you can take 180, subtract the 2 known angles, and get 99. Or you can add those 2 up, get 81, and subtract it from 180. In B, we have an isosceles triangle, which means if this one is 70, then this one, because it's opposite these 2 equal sides, are equal. So they're both 70. So in fact, we know 2 sides, or 2 angles in this triangle, even though the question looked like we only knew 1. So you could take the 180 and subtract the 70, and subtract the 70 and get that. Or of course, you could do the blue way, which is add up 70 and 70, get 140, and subtract it from 180. All right. Here's another one that you can try. Oh, sorry. Here is 2 other ones that you can try on the whiteboard. Again, I'll pause the video. You can pause the video and come back in a second for the answers. And so here are the solutions to the 2 that you could have tried on the whiteboard. The first one, you have different angles add up to 180. So it's x plus 5 first, then plus this one, plus this one. Collecting like terms gets you 3x plus 3, and then a little bit of algebra to solve our favorite equation to get 59. Although the question just says solve for x, we could stop right there and be correct. I just went a step further and said, okay, then that must be 59. This must be 59 plus 5, and this one must be 59 minus 2. In the next one, it's a quadrilateral, so instead, all of these sides, this side, or sorry, angle, this angle, this angle, and this angle, all add up to 360 degrees because it's quadrilateral. Collecting like terms, and we get 2 and 2 and 1 and 1 is 6x minus 48 equals 360. A little bit of algebra to get that x equals 68. Again, that's all the question does ask because it just says solve for x. But I did go the step further and see that this would be 68, this would 68. You plug in 68 and both of these would be 112. Add those up, 112 plus 112 plus 68, and you do get 360. And so there's an opportunity for you to practice some of the triangle properties.